Thank you for joining, all of you. Now we are going to the worksheet. Yeah, here we go. We are done till 16. Okay.
Yes, sir.
And today we'll continue from 17 with Kazi Zawad. Okay, Kazi Zawad will start reading. Kazi,
Oh, yes, sir.
17.
1 kilogram of water needs more thermal energy to raise its temperature by 1 degree Celsius than 1 kilogram of copper. Why is this?
Yeah,
A. Copper has a higher specific
you
heat
just
capacity.
tell us the answer, not all the options. You read in your mind silently, then tell us the correct option. Other students, you also think. If you have your ideas, you can raise your hand. Then I can give you the floor. So you got the answer, Kazi Zawad?
Yes, sir. I think it should be C.
You are thinking the answer
C,
is C.
A or C, sir. A or C.
So you are
Most
not
suitable, I think C.
uh, you are not thinking about B and D, right?
No, sir. D and D, I'm not totally thinking.
Yeah, you are thinking about A or C. So C you are giving priority till now.
Yes, sir.
So you check out the both the statements are correct. Huh? A, C
Yes.
both are correct, but from the point of view of context of the question, which one will be more appropriate? That one you have to choose,
I
right?
think, yes.
So you
B
see,
and D.
yeah, they are saying to raise the temperature by 1 degree Celsius, you need more thermal energy in water, right? That means water can absorb more heat than copper. Or
Yes.
in other way round, we can say it has more capacity to absorb heat, right?
Yes.
So you can remember the definition of heat capacity and specific heat capacity, right? There in the definition you got the temperature raised by 1 degree
Well, the
Celsius.
1 degree Celsius. Oh, yes, sir. A will be.
Can you remember? If it
Yes, sir.
is
Yes,
if
sir.
it is if it is for the whole object, then it is heat capacity.
Heat capacity.
But if it is for 1
Oh,
kilogram, then it
specific
is
heat capacity.
specific heat capacity. So which one now you think?
A, sir.
A.
Ah,
So
B.
got it
A,
everyone?
why B?
কোনটা লিখছে?
The answer should be A or
Oh, yeah,
B.
A, sir.
A should be B. You check.
Sir, when it would be C if it was not mentioned like 1 degree Celsius?
Wait. Now this one has some tricks. This question. Can you check that in your statement, the way it's said, which one has more specific heat capacity, water or copper?
কাজী দেখছো?
জানি না। Yes, sir. Copper, the
Which one
water,
has?
sir.
Listen,
এতে কপারের বেশি দেখাচ্ছে।
Kazi, your thinking is right. The
Yes, sir.
way you are thinking is fine. But there is one
Hmm.
trick. They are playing with you. Cambridge is playing with you, right? With the questioning. They are not only playing with you, they are also playing with the candidates. Okay, by making the question tricky. So they did not give the answer directly, they gave the answer indirectly. They could give you like water has higher specific heat capacity than copper. Then they could write water has a lower specific heat capacity than copper. The way they gave the statement, you see, 1 kilogram of water needs more thermal energy to raise its temperature by 1 degree Celsius than 1 kilogram of copper. So from this statement, we understand the specific heat capacity of water is more, right? Isn't it? Hello.
Yes,
Yes,
sir.
sir.
So, Kazi Zawad, are you understanding?
Yes,
So,
sir.
if you think that water has more specific heat capacity, that copper has less specific heat capacity, right?
Yes, sir.
So, which statement is
B,
now
B, I
wrong?
think. B.
So, look, it's not giving the answer directly, it's giving indirectly, right? Copper has a lower specific heat capacity than water. So this way you should be more careful and you should be patient, right? That how the questions are coming, how they are dealing with the questions. So is it clear, everyone?
Yes,
Hello?
Yes,
sir.
sir.
It's little bit tricky, right? The idea is simple. If you think generally you can get the idea, but the options, when they are making options, that time they made it tricky. Okay, they did not give the options directly. They did not write that water has higher specific heat capacity than copper. But they wrote copper has a higher specific heat capacity. Copper has a lower specific heat capacity than water, which is opposite to the uh, presentation in the question, right? In the main question, the way they presented, in answer they gave the presentation in opposite way, right? Hello.
Yes,
If
sir.
you all understood it, then we can go to 18. Otherwise, we will continue explaining again. What about others? They understood. Yeah, Adnan Rahim, Farabi, then Aisha, Rabi, Jawad.
Yes, sir.
Jawad is already understood. Faiza, you understood? All of you? Hello, you understood? Okay, fine. Then 18, continue. Kazi. Kazi, continue 18.
Yes, sir. The thermal energy produced by an electric heater in the minute is used to melt wax.
Yeah.
The melt wax. The wax is initially at its melting point of 60 degrees Celsius. The specific latent heat on the of the wax is 220 joules or gram. The heater supplies 70,700 joules of thermal energy to the wax. How much wax melts?
So you are asked to find mass, right? How much wax mass? You are asked to find the mass, isn't it? What is the formula related to specific latent heat, mass and heat energy? Can you remember? Hello?
Yes, sir.
Can you remember the formula? What is the formula?
Sir, specific latent heat, uh, small c equals to Q by M del theta.
Latent heat.
Sir, Cm is equal to 1 by m q by delta. Yes.
Look, they are giving you information about latent heat, not specific heat capacity. So latent heat
Oh,
formula is like this: LF. LF equals Q by M. I wrote it. could you please write on your paper these things? They who are attending class, please write these calculations in your copy. Then here we are asked to find mass, right? So we will
Yes, sir.
rearrange the formula. We will write here m equals q by lf. Now q how much?
7700.
7700,
00.
and lf you are getting 220, right?
Yes,
So
sir.
the Q is the temperature change or what it was, sir?
Q is the heat energy
Uh,
needed.
or the heat energy. Okay, sir.
Heat supplied, heat energy required. Okay, that one is Q. So what is the answer comes?
Sir,
And,
35
and the
grams.
LF, sir? I forgot the LF, sir. What was the LF?
LF is latent heat of fusion.
220.
Specific latent
Oh,
heat of
okay.
fusion. You see wax. So wax is melting, right?
Yes, sir.
So melting means fusion.
Okay, so I answer M is the mass, I think.
Yeah.
Or
So what is the answer coming?
Sir, D, sir, 35 gram.
35 gram. You got the answer. All of you got the answer. Farabi, Adnan Rahim, Faiza, Aisha, all of you are writing.
Yes, sir.
Please write. Please write. And
Okay, sir.
if your writing is over, then you send in the group, our group, so that your other friends can be benefited, right? If you think your writing is good one, you take the snap and send in the group. Okay, the solution here 7700, huh?
Yes, sir.
This is energy required, energy supplied, heat energy. Then LF is 220 joule per gram.
220.
Look, we did not change, huh? Change the
Yes,
unit
because it is in gram.
because already it is in gram and the answer is also in gram. The options are given in gram. That's why we did not change it, huh? We kept it as it is. And you see the other information is given here 3 minutes 60 degree to make you confused, right? At the beginning
Yes,
you
sir.
were confused that you will use which formula, specific heat capacity formula or specific latent heat formula. You were confused, right? Because of this information, right? They
Yeah.
gave the temperature. You thought that if there is temperature, that means it is del theta working. So be careful, huh? So here is coming 35. So it is D, right? 35 grams. Please write. Everyone should write the explanation also, huh? The formula and the numericals I'm writing. This way you should write. So is it done? Question number 18 is done.
Yes, sir.
Then we can continue 19, right?
Yeah.
Okay, so 19, who will read? Rabi. Rabi, you read 19. Rabi, please read 19.
sir, I think he has problem.
But his mic
Technical.
is okay. It's showing his mic is okay, but it's muted. And then
Oh,
if Rabi can't, then Aisha, you can read. Rabi is there? Rabi or Aisha? Aisha, you can read. Aisha, then Farabi. Farabi, you can read. What happened? They are attending, but they are not taking part. Then Faiza. Hello, Faiza. Yes. Faiza, can you read this? Question 19.
What is rapid heat of vaporization? Number A. The heat required to make molecules expand. B. The heat required to make molecules expand and move toward upward. C. The expand heat required to make molecules move upward. D. The heat required to make molecules move faster.
So which one? Which one is your option? Which one you are picking?
B.
Hmm? Bangladesh? Are you saying Bangladesh? B.
Sir, I'm going for C, sir. C for correct answer.
Yeah, you are right because you attended previous classes. You know the explanation. But what about others? You see, Faiza, you chose B. Faiza?
Yes.
Okay, look, you see here is written make molecules expand. And you take these notes in your copy that molecules can never be expanded. Only gas expands. Molecules move far apart. Okay. This one we are repeating this statement we are repeating in last three classes also, today's class also. So molecules can never be expanded. Only they can move far apart. Okay. Now it's during the time of vaporization when the container is open, right? As the container is open, then molecules move far apart. When D is possible, if the container is sealed and we are increasing the temperature, that time the answer is D. Is it
Hello,
clear?
sir.
Is it clear?
Yes,
Hello?
sir.
So our answer is C.
Yes, sir.
Our answer is C. Okay,
Yeah.
Faiza, continue 20.
An electric shower takes in cold water at 70 degrees Celsius. The shower gives 6,000 joules of energy every second to the cold water and heats it to 37 degrees Celsius. The specific heat capacity of water is 4,200 joules. What is the mass of hot water supplied to the shower in 1 second?
Okay, they are asking you about the mass, right? And the electric shower is taking in cold water at 17 degrees Celsius. The shower gives 6,000 joules of energy every second, and the cold water and heats it to 37 degrees Celsius, right? The specific heat capacity of water is 4,200 joules per kg degree Celsius. Okay, what is the mass of water supplied by the shower in 1 second? So
Sir,
you
I
are
am going for C, sir. C for correct answer, sir.
C for correct answer.
Yes, sir.
Fine, you are going for C is correct answer, but we should also have the explanation, right?
Yes, sir.
How you are getting this correct answer C?
Sir,
Hmm?
can I explain, sir?
Yes, please explain, please.
Yes, sir. The specific heat capacity, formula specific heat capacity is uh, small c equals Q by M del theta. So we can arrange it. Q is the energy supplied or energy given. That is 6,000 joules, and uh, we can also just exchange
Can
estimates
you
like.
can you can you please write on the screen which formula you are using? That one make
Yes, sir.
everyone it's more
Okay, sir.
understandable, right?
Yes, sir.
You have lots of space on the screen anywhere you can write. Yes, m equals. Can you write in text form? That will be
Sir,
easier. Is it?
sir, actually, I'm using a mobile. That's why.
Yeah, that's why
There is
text will help you, right? Text you can
yeah.
use, right? So your
No, sir, I cannot use
the
text.
equation you wrote first. This was C equals
Yes,
Q.
sir. I'm just sir.
C
Sir, C
equals
equals Q by M del theta. I'm just
okay. Q by
M del theta.
M del theta, right? Del
Yes, sir.
theta. Uh, here there is no option for here writing theta for me, so I'm writing here del theta, right? That is the problem. We don't have any options here to write theta. So I'm writing again here m del theta, right? Is it okay? C
Yes,
equals
sir.
q by m del theta. So they are asking you to find the mass. Now we are writing
M
m here
equals
c by q by c del theta, right?
yes, sir. C by Q del.
Q by c del theta. Then what is your del theta?
Sir, del theta is 20, sir.
Del theta is
37 minus
20.
17. Yes, sir.
Yes, so everyone
37 minus
understood it.
17.
Everyone understood it. How we are getting del theta? Del theta means the difference in temperature. Theta 2 minus theta 1. That is del
Sir, we
theta.
can also do in the formula you gave, like in the 18 number also.
Yeah, yeah. So 18
Same.
number, the formula is for
No, it is for
specific latent heat. Wait. Kazi, here we
Yes, sir.
got the formula for specific latent heat. That is LF equals Q by M. Mind it, Kazi, it's for specific latent heat.
Yeah, yeah, understood, sir.
When there is no temperature change, it's constant temperature. But specific heat capacity is happening in temperature change. That's why we are getting del theta, right? Isn't it? So
Yes, sir, yes,
we
sir.
are now putting the values. Don't mix up. When it is specific heat capacity, it is T equals Q by M del theta, and when it is latent heat, it is LF divided by Q by M. Now Q you are getting 6,000, C you are getting 4200, and temperature change you are getting 20. So what is your answer coming?
sir 0.071429.
Okay, then
Okay,
you can
sir. Q is the heat energy like absorb or given. No, sir. Like given.
Yes, sir.
Or sir,
Q.
del theta is the sir
del
temperature
theta
change
is
Del
the
theta is
and
the
temperature
difference.
change in temperature.
oh,
Theta 2 minus theta 1, that is del theta. You have here 37 degrees Celsius, it is theta 2, and 17
del
degrees
theta.
Celsius, it is theta 1. So theta 2 minus theta 1, it is del theta. Is it
Oh,
clear?
okay, sir. Yes, sir.
So how much is your del theta? 20, right?
Yes, sir.
So you are getting how much? The answer, everyone? Sat said 0.071. What about you, others? Your answer is coming also same.
Sir, why multiplied with sir the specific heat?
Look, we got this formula, right? C equals
Yes, sir.
Q by M del theta, right?
Yes, sir.
But they are asking you mass. That's why we are taking mass here as C is coming down. Cross
Oh, there
multiplication.
is Q also. Oh, sir, I didn't know the Q. C.
This
Sorry,
one
sir.
is Q. Okay,
Yes,
this
sir.
one
Yes,
is Q. Just C is coming down and M is going up.
yes, sir.
Now it's clear.
Yes, sir.
So what is your answer coming? Check.
Sir, C.
The answer is coming C.
Yes, sir.
Okay. So it's
Okay,
clear
sir.
to
And
you.
what is the C, sir? C is equal to Q by M del theta.
C is specific heat capacity.
Space heat capacity. Okay.
This one,
Small c,
yeah,
small
small
c,
c. Small c is specific heat capacity.
and big
Okay,
C is
heat
only the
capacity.
only heat capacity.
Only heat capacity. Okay, sir.
And in small c, you are getting Q by M del theta. In big C, you will get only Q by del theta. Is it clear?
Yes, sir.
Because for small c, we are dividing by the mass. For big C, we are not dividing by the mass. We are only taking the whole object. Is it clear, everyone? Can we go to next one? 21.
Yes, sir. Yes,
Okay.
sir.
We are going to now next question. No problem. 21. Yeah, this one is
Sir, how
again.
many more MCQs do you have?
We have 30 MCQs.
Sir, today our class time is over. Sir, can we proceed? Can we do this in our next class, sir?
Our class time is
Yes,
over.
sir. Yes.
Sir, yes, sir.
So we started at 11:15
Yeah,
and
sir.
our class will be till 11:55.
Sir, 55 or 50, sir?
It should be 40 minutes. Then you calculate 11:55, isn't it?
Oh, yes, sir.
So let us do another one, at least one or two more questions.
Okay, sir. Yes, sir.
Yeah. So now I ask another student, Shafkat. Hello, Shafkat. Shafkat. Shafkat is there.
Yes, sir. Yes, sir.
Yeah, continue 21.
A gas is in a sealed container of constant volume. The gas is heated and the pressure of the gas on the walls of the container increases. How do the particles of the gas cause this increase in pressure?
Very nice question. Awesome question. Yeah. Particles. They are talking about the particles.
Sir, there was the same question, sir.
The gas is heated.
Yeah, there was the same question, but same people were not present. Right?
Sir, should I give the answer, sir?
I think
Wait,
B,
wait,
sir.
wait for them. Let them think. Brainstorming should be there, right?
Oh, no, 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 not B. Sorry, sir. Let me think, sir. Sir, C, sir. I think.
Yeah,
Yes.
C for
Sir,
hydrogen.
C, sir. The chemistry, sir.
Yeah, they heat the container more frequently. This is one option. And there is another one, they vibrate faster.
Way 5 faster, yes.
And there is, option they expand, it is wrong, right? Particles cannot expand. Particles means here molecules, they cannot expand.
But it also only gas can expand.
So they heat the container more frequently, right? You are choosing this one. Why?
Yes,
Why
sir.
they
C
are?
will be the correct answer, sir. 100%.
Okay. So why it is? Can you explain, anyone?
Yes, sir, because it is gaining more kinetic energy.
Yeah, then
And
And
sir,
because
the
of
gas
kinetic
cannot
energy,
move out. That's why it is sealed
yes.
inside. The
the
particle can
container is
hit
sealed.
the
That's why
wall.
it cannot escape, and it is hitting the walls of the container more frequently.
Okay, so your answer is C, right?
Yes, sir.
Okay, very good. Then continue 22. Shafkat, continue 22.
Some of the liquid in a dish evaporates as shown in the diagrams, before evaporation and after evaporation. Which molecules have the liquid and which molecules in the liquid have greater average kinetic energy?
The similar one we did before, right? Shafkat?
Yes, sir.
Yes.
Yesterday we did a similar one.
Sir, should I tell, sir?
Sir, molecule, oh wait, the molecules. Sir, A, sir, I think.
Yes, correct. Your answer is
Yes.
correct.
A for Africa.
Yeah, very good. Very good. Then 23. Already you did many questions.
Sir, can you ask Sak to read this?
Why?
Sir, he knows all the answers, that's why.
Sir, what was the question? The above 22.
22 you did not see yet.
কই আছে দিদি?
No, sir, I didn't see the question.
You were somewhere else. Already we did it.
Yes, I understood, sir. Yes, I heard it.
Okay, the answer is A. Huh? Then 23. Shafkat, you read.
Okay, sir, 23.
Sir, I
An
think over.
insulated beaker contains 300 gram of water initially at 30 degrees Celsius. Water at 100 degrees Celsius is added until the temperature of the mixture reaches 50 degrees Celsius. The specific heat capacity of water is 4.2 joule per gram degree Celsius. How much water is added?
Yes, this one is a bit lengthy questions. We have here two steps to do. So in our next class, we'll continue it. Okay. So everyone,
Okay,
you
sir.
please join in our next class. I'm really happy that you all joined, and we want more students to join in next class. Okay. Thank you so much. Allah Hafiz.
আল্লাহ হাফেজ স্যার, আসসালামু আলাইকুম।
Walaikum salam.